So today we start our study of kinematics and dynamics. So today we're going to look at what scalar quantities are, what vector quantities are, what is the difference between distance and displacement, how to calculate displacement using vector notation, what is velocity, what is acceleration, and I think we're going to end with acceleration. So this would be quite an interesting lecture, and this is where physics actually begins. So if you really want to understand physics, it's practically this topic, because each and every year you're going to have at least one or two motion graphs. So we begin our study of physics in terms of trying to understand what a vector quantity is and what a scalar quantity is. So we have to know the differences, because last time I told you that in physics we study things known as physical quantities. Physical quantities. And we said that a physical quantity is the measurable characteristic that an object has. And these physical quantities can be scalar quantities and they can be vector quantities. And a physical quantity always has to have two things. It has to have a numerical value, numerical meaning numbers, so it has to have a numerical value, and it also has to have units. For example, a scalar quantity like 25 kg for mass, we have a numerical value there, and we have got the unit, which is kilograms. Or a vector quantity like 35 meters per second squared due east. This is a velocity, so we have got a magnitude and a numerical value, which is considered the magnitude, and also the units. So these are the physical quantities. And scalar quantities, we say they just have this numerical value, they only have magnitude. So these are quantities that just have magnitude without direction. Like I told you last time, you don't go shopping for sugar and then you ask someone saying, I want a 2 kg sugar due east. You don't say that. These are just quantities that just have size, and size means magnitude. So if a question comes saying, define what a scalar quantity is, you tell them, all right, this is a physical quantity. You tell them remember, you tell them it's a physical quantity. So physical quantity, which just has magnitude only without direction. Then they say, all right, give some examples of physical quantities. You're going to tell them, all right, temperature is a physical quantity. We just say 76 degrees Celsius or 34 degrees Celsius. We don't say 25 degrees Celsius due east. No, it just has a numerical value and a given magnitude. So it just has a magnitude without direction. We also have mass, like the kg example, kinetic energy, all types of energy. Let me just say energy is a scalar quantity. So you can just say scalar quantity as energy. Time, amount of substance, like the Moore concept, no direction, and also density. The good example, if they say give a list of 3 types of scalar quantities, you can just say this formula: density is equal to mass over volume. Then you tell them, all right, density is a scalar quantity, mass is a scalar quantity, volume is also a scalar quantity. So at least here you can define, you get max, and you can also have 3 examples: density, mass, and volume. For this one, energy, they usually bring it in a multiple choice to confuse you. So remember, energy is a scalar quantity. Energy does not have a given direction. It's just measured in joules. It's a physical quantity measured in joules. Are we together on scalar quantities? Have you understood what scalar quantities are? All right. Let's move on to vector quantities, which can be a little bit complex because we have to know how to add two or more given vectors using the parallelogram rule or the triangle rule of addition of vectors. So vectors specify not only the size but also the direction. So a vector is different from a scalar quantity because it has the size or magnitude. It has size or magnitude, and it also has size or magnitude and direction. And usually in physics as well as in mathematics, we're going to do vectors in physics, but in math, they are sort of different because in mathematics, they just want you to follow known paths. You're going to have maybe a triangle like so, then they are going to say find the given vector in terms of A, B, or C. Then you just have to follow known paths and you find given vectors. Have you seen such vectors before in mathematics?
Yes.
So we're going to do these types of vectors in mathematics. These are known as geometric vectors, meaning vectors on the x or y plane that are in the form of shapes. So it can be a triangle or it can be a trapezium, and then you have to follow known paths to find the given vector. However, in physics, when we're adding vectors, we use something known as the parallelogram rule of addition, a parallelogram rule or the triangle rule of addition of vectors. So when it comes to vectors such as displacement, we just don't add them. You're going to see in the next slide. But what I want you to know, vector quantities have got magnitude and direction, and they are usually denoted by an arrowhead. So you're going to have an arrow like that, denoting the vector. This is the head of the vector, and this is the tail of the vector. And vectors are usually put together head to tail. And the magnitude of this vector is the size of the arrowhead. So we can denote this vector as either A with a dash on top or A with an arrow on top. I usually like to say A with a dash on top. So you can say, or sometimes you can say small letter A with a dash on top, or you can say small letter A with a dash below, or capital letter A with a dash, depending on how you've named that vector. So showing an arrow on top or below shows the magnitude of this vector or the size. So remember, a vector is arranged from the tail to the head of the vector. If you want to add another vector, you have to start from the head there. So from the head, you put another tail and you put another vector like so. So head to tail notation. So that's the tail of the new vector, and that's the head of the other vector. This was vector A. We can name this vector vector B, showing the magnitude of the vector with the arrow on top or the arrow below. So a vector is a physical quantity that has both magnitude and direction. Addition of vectors, we use the parallelogram rule, which I'm going to explain in the next slide. Vectors are arranged from the tail of the vector to the head of the vector. The size of the vector or the length of the vector is called the magnitude. It can be represented by an arrow on top or an arrow below. If you are trying to add vectors, you have to add them from head to tail, head to tail. So that's a vector, tail, head to tail, you put another vector like so. Addition of vectors, we use the parallelogram rule. You don't just say 5 newtons plus 5 newtons giving you 10 newtons. No, you don't do that with vectors. You have to follow the parallelogram rule of vectors, meaning you have to know the given direction of the given vector. You can add them directly like this if they are going in the same direction. If it's 5 newtons going this side, and another 5 newtons going this side, going in the same direction, head to tail, head to tail, you can say, all right, this is 10 newtons. But when they are going in different directions, you just can't say 5 newtons plus 5 newtons. Let me explain this further. So these are examples of vector quantities: displacement, velocity, acceleration, momentum, force, very huge vector. So I want you to know at least these. So displacement, velocity, acceleration, momentum, and force. Displacement, which is the distance moved in a specific direction; velocity, which is the rate of change of speed with time; acceleration, which is the rate of change of velocity with time, acceleration; momentum, which is the force applied per unit time; and also force, which is a pull or a push, and which is equal to mass times acceleration. So the acceleration on the formula for force makes it a vector quantity. So all these are examples of vector quantities. So again, a question comes: define a vector quantity. You say this is a physical quantity that has both magnitude and direction. Then give some examples of vectors. You say, all right, displacement, velocity, acceleration, and force. If they say 3, you can mention these. For now, momentum, you don't know it as such. I might explain this, but it's a little bit, yeah, I'll have to explain this. I'm sure it's in the syllabus. And also force. So these are the examples of given vectors. Remember, they have both magnitude and direction. So what exactly is the parallelogram rule of addition of vectors? So remember, vectors are straight lines. Since vectors are straight lines, they'll always form geometric figures with a 90-degree angle being formed. Not necessarily always a 90-degree angle, but it's usually a 90-degree angle being formed when you arrange a vector from head to tail. So given this vector, we have got 2 given vectors on the x or y plane. One vector is moving a certain number of units to the east. It's moving like that. And this vector is vector x. Let me draw a proper diagram. So we have got one vector moving towards the east. One vector is moving like that. Oh. Arrow. So one vector is moving like so. And this vector and the other vector is moving like so. This board. The other vector is moving in the other direction like so. These vectors don't want to be drawn. It's moving like so. Okay, something like that. Then enhance this diagram. Let me move it there. Okay, much better. So we have got 2 different vectors here. One is moving in the east direction because it's moving that way. So that's the head of this vector. And the other vector is moving towards the north. So this is the vector there. So vector x, we can put the magnitude on top there, and vector y, we can put the magnitude like that. their resultant vector, the resultant vector is going to start from the tail of the first vector towards the head of the second vector. So let me write this down here. So the resultant vector will start from the tail of the first vector to the head of the second vector. So this is the first vector, that's the second vector. This is the tail of the first vector, and the resultant will be from the tail of the first vector to the head of the second vector. So this is the resultant from the vector addition x plus y. Are we following? So this is the resultant vector. If we add x plus y, the resultant vector will be x plus y. This will be the resultant vector there. So let's give this resultant vector a name. So this resultant vector, here in the diagram, they gave it, they denoted it as A. So how can we find the resultant vector A? We have to use the Pythagoras theorem. Pythagoras theorem. I haven't taught you the Pythagoras theorem yet in math, but let me tell you what it is. So the Pythagoras theorem gives the relationship between the interior angle of a right angle triangle in relation to the sides. So it states c squared is equal to a squared plus b squared. So this c squared is the hypotenuse. So this c squared is the hypotenuse, and a squared and b squared are the two adjacent sides. So how do I find the hypotenuse? I go at the tip of this right angle triangle there, and I follow that tip edge until it hits a side. So from the tip to the side, that will become the hypotenuse. So you've seen that the hypotenuse is this resultant vector, the magnitude of this resultant vector, x plus y. Called it vector A. So we'll say vector A squared is equal to, then these are the two adjacent sides. This can be A, this can be B, or vice versa. So where there is A there, we'll put vector x squared, plus where there is B there, we'll put y squared. So the Pythagoras theorem gives a relationship between the interior angle, this 90-degree, in relation to the sides. So a right angle triangle is going to have three sides. It's going to have one hypotenuse and two adjacent sides. Let's say you are seated in between your two sisters. Sister number one is on your left, sister number two is on your right. So this is you, you are the angle here. You are the angle there. You are seated on a couch watching the television, right? Imagine you are seated on a couch watching television, and then you point your hand, you get the remote, you want to change the channel, you get the remote and you point it towards the TV. So the TV is going to be the hypotenuse, that's one side. And then either of your sisters, either the one on your left or the one on your right, will be your two adjacent sides. So that's how the Pythagoras theorem is. It gives the relationship between the interior angle and the three given sides of the right angle triangle, which include one hypotenuse, which you can find by following from one edge to the side, and any of the two adjacent sides. It doesn't matter which one you start with. So from here, our hypotenuse was this given vector here, x plus y, which we denoted as A. So a squared plus any of these two adjacent sides, vector x or vector y or and vector x. It doesn't matter which one you start with, because addition 2 plus 3 is the same as 3 plus 2. I think this is commutative law. I'm not so sure, but it doesn't matter which one you start with. You still get the same answer at the end of the day. So commutative law. 2 plus 3 is the same as 3 plus 2. So it doesn't matter. I can say x squared plus y squared or y squared plus x squared. So here I was substituting. So this is the formula, the Pythagoras theorem formula, and then I'm substituting. The hypotenuse is this a squared, the a is the, and b are the two adjacent sides, x and y. So where there is x, where there is a, I put x, where there is b, I put y, I substitute, but the formula has squares, so I have to square the x, I also have to square the y. So now I want this a to be the subject of the formula. So I have to square both the left-hand side and the right-hand side. So if I square root both the left-hand side and the right-hand side, this a will be alone. So a, the magnitude of the given vector, the size of the given vector, will be the square root of x squared plus y squared. So this is known as the triangle rule or the parallelogram rule of vector addition. Why parallelogram rule? Because that vector, vector y, can go like that. It's the same y vector, and this vector there can go like that. It will be the same x vector, but the resultant will still be the same. It will be as a result of the formation of a right-angled triangle. Then you use Pythagoras theorem to find the magnitude of the given vector. So you won't be able to understand this unless if we do some questions. So let's try to practice some questions. I'm sure I prepared some questions somewhere down there. We're going to find questions on how to use vectors in terms of displacement. So don't get freaked out or don't get too discouraged. So let's start our discussion with kinematics, which is kinematics is just the study of motion without an explanation to what's causing that motion. So we're just saying, all right, a car is moving, it stops, it accelerates, it stops. But when we look at dynamics, we're going to say, all right, it's the application of a force that's causing that motion. So differences between, if you've encountered these words like kinematics and dynamics, kinematics, we're studying motion without necessarily knowing what's causing the motion. We just want to explain motion in terms of time intervals, right? This kilometers per hour, this was kilometers, etc. But when it comes to dynamics, we now have to explain what is causing that motion in terms of forces. Is there a resultant force causing the motion? What are Newton's laws? So that's what we're going to focus on in terms of dynamics. But kinematics, remember, easy, straightforward, just the study of motion without a specific cause to the motion. All right, so that's what I was saying here. And to know kinematics, we have to know a few terminologies. We have to know what displacement is. So displacement is a vector quantity, and it's the distance moved. Displacement is practically distance. So displacement is the distance moved, but the difference between distance and displacement is that displacement is a vector. So this one is the distance moved in a specific direction. So displacement becomes the distance moved in a specific direction. Then velocity, we're going to know what velocity is soon, but we first have to know what speed is. But I'll just say, all right, velocity is the rate of change of speed with time. That's what velocity is. Then acceleration will be the rate of change of velocity with time. We're going to encounter these terms individually in the coming slides. So this diagram here shows the difference between distance and displacement. So displacement takes into consideration, so displacement, I would denote it as S. It takes into consideration your final position minus your initial position. So displacement is final minus initial position. That would be your displacement. But distance, you have to take into account each and every corner bump that you encountered and add it. So if we start from X going to B, that would be your displacement vector. So remember, displacement is a vector. But your speed, you're going to be adding. Maybe you started from there, but you found a road, another road, you made a turn, you stopped at a filling station, you encountered roadblocks, traffic, etc., until you got to your destination. So distance will be the entire load of your destination, this entire thing. You just have to continue moving and adding and adding and adding until you get to your final destination. You add all the points. However, displacement, it's just a vector. So this person maybe moved due east, maybe 25 kilometers due east. So maybe after adding all these, you get 25 kilometers as your total distance, but displacement will say 25 kilometers due east, and it's a vector. No wonder it's denoted by a straight line like so, specifying the specific direction. So that's the difference between displacement and distance. So what about speed and velocity? So speed is distance over time, while velocity is the rate of change over velocity, final velocity minus, it's the rate of change of speed with time. Rate of change of speed with time. So where there is velocity, there is change in speed. And where there is speed, there is a change in distance, or you can say change in displacement. But later on, when we look at the uh, speed time graph, you're going to discover that for motion in a straight line, there is not necessarily that much difference between speed and velocity, because they'll be talking about the same thing. No wonder here, by definition here, they are saying rate of change of distance, and for velocity, they are saying rate of change of displacement. But they are for this definition, they mean for motion in a straight line. For motion in a straight line. So when you see these definitions, please don't get confused. There is not much of a difference between speed and velocity when we look at motion in a straight line. The only difference would be the numerator. Here it will be specifying distance, but the other one will be specifying velocity. But the formulas that I want you to use is speed. Let me say speed is equal to distance over time, and will be uh, velocity will be the rate of change of speed with time. So you can be, what am I saying? Speed is equals to distance over time. Velocity is the rate of change of displacement with time, or change of speed with time. Velocity. You can now find that I'm trying to explain what acceleration is. All right, well, we're going to encounter these things very soon. Okay, but I'm sure I was explaining the right things. For motion in a straight line, there's not that much difference between velocity or speed. Because I wanted to say velocity is final velocity minus initial velocity over time. Then I realized that this is actually the formula for acceleration, which is the rate of change of velocity with time, which is the rate of change of velocity with time. Therefore, velocity is the same thing. Velocity is also distance over time, actually. Yeah, that's true. Velocity is also distance over time, but the only difference between speed and velocity is that this d is displacement over time, while speed is distance over time. All right, so are you with me? Velocity, displacement over time, speed, distance over time. But for motion in a straight line, when we start looking at our speed time graph, there won't be that much of a difference between velocity and displacement. Easter holiday can make you forget simple things. Okay, so there will always be a question in your exam, always, every time there will be a question which will tell you, calculate the average speed. In paper 2, there will be a question that will come and it will say, calculate average speed. Please use this formula. Just by stating the formula, you're going to get marks. So you tell them every time you see this word average speed, average speed is total distance over total time. So you take into consideration the entire journey in terms of distance and the entire journey in terms of time. So average speed is total distance over total time. Please do not forget this formula. So remember this formula. It will earn you marks in your exam. Remember this. Average speed is total distance over total time. Okay, so let's do a few practice questions so that we try to solidify the few things that we've learned. So we have a question here which says, if a car is taken from the garage, it's driven 100 meters, so data. So total distance, the total distance that this car has been driven is 100 kilometers before returning to the garage after 2 hours. So total time is 2 hours. Then the question says, all right, calculate average speed. So it just has to click in your head, all right? So they want us to calculate average speed. The first thing that you tell them is the formula. You tell the examiner, I know the formula for average speed. So you say average speed. Average speed is total distance over total time. You get a mark. Then you substitute, all right, from the data, total distance is 100 kilometers, 100 kilometers, and the total time is 2 hours. If you divide that, so remember in physics, you can go in with your calculator. If you divide that, it will be 50 kilometers per hour as your average speed. So this is how you calculate average speed. Make sure so you get another mark there. So maybe you also get a mark for substitution. So they say 3 marks. You get 1 mark for formula, 1 mark for substituting in the formula, the last mark for your final answer. So at least even if you messed up somewhere there, you can still get 2 marks out of 3. That's how physics is. The examiner, the one marking your paper, will try by all means to look for marks. Where can I give these students some marks? So always give always give the examiner some space where they can try to allocate you some marks. And one of the good ways to help the examiner give you some marks is, have you been able to state the formula adequately? Have you been able to substitute in the formula accurately? Have you used the correct units? And have you found the final answer? So even if your answer is wrong, the examiner will still give you marks for correct formula usage and for correct substitution usage. All right, so this is what I was saying. So velocity is the distance yes, okay. I knew we would find this. Velocity is the distance traveled per unit time in a specific direction, I see. So velocity is distance traveled in a specific direction. Because velocity is going in a specific direction, it's different from speed. So speed, formula for speed is distance over time. You have to know this. But the formula for velocity, will be displacement over time. What's the difference between between distance and velocity? Remember, between distance and displacement. Remember, displacement is a vector specifying the direction and the magnitude. So that's displacement. While speed will be that, just adding everything, your entire journey from start until the end, without taking into consideration of the direction. So that's the difference between speed. But again, remember, in a straight line, there's no difference between speed and velocity. This only applies for motion in a straight line when we're looking at our motion time graphs. But by definition, by formula, you'll be doing the same thing. Speed, distance over time, velocity, displacement over time. So know your definitions. So speed, distance moved per specific time, velocity, distance moved in a specific time in a specified direction. So distance moved per unit time in a specified direction. So because of the specified direction, velocity is a vector. And because of this distance here, speed is a scalar quantity. All right, let's try to solve this question. Are we together?
Yes.
All right, don't worry, I'll send you this video. So this video will be extremely important for your understanding of physics. So make sure you just try to revise as much as possible so that things can just go into your head properly. Okay, where are we? So let's try to analyze this question. This question looks a little bit intense. So we have a cyclist. So this cyclist travels 6 kilometers due east. So this is already telling you that this is displacement because we have distance and a specified direction. So 6 kilometers due east, and then takes a turn to travel a further 8 kilometers due north. Another 8 kilometers due north. The whole journey takes 2 hours. So this is the total time. So the entire journey takes 2 hours. Question 1, calculate the distance traveled by the cyclist. So remember, distance we're just adding. We don't care about the direction that this cyclist took. So the distance will just be 6 kilometers plus 8 kilometers, right? So 6 plus 8 kilometers, our distance will be 14,
40
right?
kilometers.
Exactly, 14 kilometers. So that would be our distance. We are just adding. So here we're okay. We have our 14 kilometers there. So you can, when you write this question, you say solutions underneath. So this would be 14 kilometers, like so. Then the next question says the average speed of the cyclist. So when it clicks into your head, you'll be like, ooh, average speed. I've known this. So first of all, to get the full marks, I have to first state the formula for average speed. I'm going to say, okay, average speed is total distance, total distance over total,
Okay, time.
right? So average speed is total distance over total time. We just calculated the total distance as 14 kilometers, and the total time is 2 hours, 2 hours. Therefore, our average speed will be 7 kilometers per hour.
Okay.
So this is our average speed, and this is how your work has to look like. You first state the formula, you substitute, you give the correct answer with the right units. So our average speed will be 7 kilometers per hour. So now the question says the displacement of the cyclist. Things are about to become interesting in the final two questions, because for distance, we just added 8 plus 6 kilometers and we found 14 kilometers. But for displacement, we have to use the triangle rule of addition of vectors. So let's try to draw the motion of this cyclist. So this cyclist, let's draw the first displacement vector, which says 6 kilometers due east. So this one went 6 kilometers like so, right? This is 6 kilometers due east. Then the second part of the journey is 8 kilometers due north. So they paused and then went north. So they went up like that. Ooh, drawing on the board without a ruler. So they went north like so.
Zero all the way, the jungle all the way. Yay!
Okay. So we're saying 8 kilometers due north. So if you remember we're calculating displacement. So 8 kilometers due east. So remember, this is the tail and the head of the vector. I'm going to join the next vector at the tail going towards the head. So this is how I'm going to add these two vectors from head to tail. So this is how I'm going to arrange these vectors. So we arrange the vectors from head to tail, but the resultant vector, remember I said it to start from the tail of the first vector going to the head of the second vector. So that's the resultant that we have to find there. That's the resultant that we're going to find. So we're going to call this resultant vector. Let's call it X. And let's call this first vector, which is 6 kilometers due east, vector A. And let's call this vector, which is 8 kilometers due north, vector B. And the resultant, we'll call it vector X, like so. So let me just run it through one more time before we start solving using Pythagoras theorem. We first have to plot the motion of the cyclist. The first part of the motion of the cyclist, they went 6 kilometers due east. No wonder the arrow there is going due east like so. So this is 6 kilometers due east. Then we have to add another vector from the head of this vector going north, because they said 8 kilometers due north. So we write the vector like that, and they meet at a 90-degree angle like so. Then the resultant vector will start from the tail of this vector to the head of the second vector. Tail of the first vector to the head of the second vector. So That's the resultant displacement that we want to find. To make calculations easy in terms of substitution, we're going to say we'll call this 6 kilometers due east vector A, and this 8 kilometers due north vector B. And we'll say the resultant is vector X, like that. So we have to use Pythagoras theorem. We're going to say c squared is equal to a squared plus b squared. How do I find my hypotenuse? I go to the edge of that angle and I go like so. So this arrowhead there is pointing to the resultant. So I'll say x squared is equal to, then the two adjacent sides are a squared plus b squared, because that's what we named them. Then we substitute x squared is equal to 6 squared plus 8 squared. X squared is equal to, this is 6 times 6, it would be 36. I think 8 plus 8 is 64. I'm not so sure. Here, 64. Then if we add, let me complete it here so that you can see. It says x squared is equal to 36 plus 64 plus, that would be 100. So x squared will be 100. To get rid of this square, I'll square root both the left-hand side and the right-hand side. That cancels, so x will be, the square root of 100 will be 10. So the resultant vector is 10 kilometers, where is it, boy? East of north. So that's the displacement. You can just say 10 kilometers is the displacement, east, north, because the vector is going in the east direction and in the north direction. So we can say east of north. So this is how we calculate the displacement. Way different from speed, right? Speed was 14 kilometers, but displacement is 10 kilometers east of north. So watch this video, revise, know how to use Pythagoras theorem. So the displacement is 10 kilometers east of north. So let's now find the average velocity. The average velocity. Here we just use the formula for velocity. And we're going to say, unlike speed, velocity is displacement over time. Unlike speed, velocity is displacement over time. So let's calculate the velocity. So we'll say velocity. Velocity is displacement over time. The displacement, we just found it as 10 kilometers, and the time still remains 2 hours. So our velocity will be 5 kilometers exactly hour. So 5 kilometers per hour. So that's the difference between scalar quantities, vector quantities, difference between speed, and difference between velocity. So, oh, there's one last question here. I think one more question. Then we'll start with acceleration next week and acceleration graphs. So we'll do acceleration and we'll look at the graphical analysis next week so that I don't load you with that much data. Let's end on this multiple choice question. So they are saying a car travels along the route PQRST in 30 minutes. So this is the total time. So that's the total time. So now they are saying, what is the average speed of the car? So as usual, you say average speed is total distance over total time. And remember, so how are we going to calculate the total distance? We'll just say 10 plus 5 plus 10 plus 5. So let's say 10 plus 5 plus 10 plus 5. That would be 30 kilometers. So total distance 30 kilometers over total time 30 minutes. But we won't use this minute. Standard SI unit is kilometers per hour or meters per second. So these are the standard SI units that we use. We don't use minutes. We either use kilometers per hour or meters per second. So we have to convert this time in minutes to time in hours. How do we do that? We can say 1 hour is equivalent to 60 minutes. 30 minutes is equivalent to X hours. We cross multiply our X Okay, let me just say X. Actually, no, it's fine. So we divide both sides by age 60. So we're just dividing by 60. The hours will cancel. So if we say 30 divided by 60, it will give us 0.5 hours. So like half an hour should be the answer. Yeah, half an hour. So 30 minutes is actually half an hour, which makes sense. So instead of saying 30 minutes there, we're going to say 0.5 hours. 0.5 hours. So we're going to say 30 divided by 0.5. We're going to get 60 kilometers per hour as our final answer. So this one was simple because we do know that average speed is total distance over total time. Total distance, we just had to add everything to get 30 kilometers, but we had to use some unit conversions. We had to say 1 hour is equal to 60 minutes. Then we start, then we say how many minutes will be equal to 30, how many hours will be equivalent to 30 minutes. We cross multiply xh times 60, it will be xh60 is equal to 1 hour times 30 minutes would be 30 minute hour. We divide both sides by h60 over h60. The hours cancelled, the h60 cancelled. It became 60 into 30 divided by 60, it became half an hour, so 0.5 hours. We substitute it properly, it would be 30 kilometers over 0.5 hours, half an hour, to give us 30 kilometers per hour. So just remember the standard SI units, we never use minutes. We either use kilometers per hour or meters per second. So in our next lecture, we're going to talk about acceleration as the rate of change of velocity with time. And we're going to look at various motion graphs. We'll look at more examples, and we'll look at the speed time graph, velocity time graph, and we'll look at a variety of questions and scenarios that we can use to calculate average speed. And this lecture has to be like your everyday physics practice, because this topic is literally 20% of your physics exam. It's a huge, huge topic. You'll find motion graphs in multiple choice. You'll find motion graphs carrying 20 marks in section B. So this topic, you have to follow it. So let me just send you the math video and these physics notes and the math notes so that you can know we've rested enough so that we can go back to studying. You are ready to go back to studying?
Yes.
All right, okay, thank you. I'll end the lecture and let me send you everything immediately via email. Make sure you download them. All right. See you tomorrow for mathematics. Remember, we're doing trigonometry tomorrow, a paper 2 topic. I'll see you tomorrow.